In this video, I'm going to go through and give you an introduction to long division with polynomials, but I'm going to first start out with long division with whole numbers, either with a remainder or without a remainder, and I want to use the standard algorithm that they teach in the United States. And I'm going to show you that this algorithm that we use for whole numbers is really no different than how we're going to do the long division with polynomials. Okay, so let's go ahead and get started. So this is 4,488 divided by 12. So I'm going to go ahead and put that 12 outside and then set up my little bar here and say 4,488. Okay, so typically we look at just the first digit and we say, well, how many times does 12 go into 4? Well, it doesn't, so we have to add another digit. So how about 12 into 44? And that's going to be 3 times. So we come back, we multiply here. 3 times 12 is 36. And then we go ahead and we subtract, don't we? So this 36 is positive, but we actually need to subtract. So I'm really changing that sign. And then this subtraction gives me 8. And then I'm going to bring down this 8. And how many times does 12 go into 88? Well, that's 7. So 7 times 12 is 84. And I'm going to subtract these, so change this sign from positive to negative. When I subtract, it makes 4. And then I bring down this last digit, which is an 8. And how many times does 12 go into 48? Well, 4 times, nice and even. So when I multiply back through, I get 48. And I subtract, and I get 0. So I know that I have no remainder. So what this says is 12 divides 4,488 evenly, and it does so 374 times without remainder. Okay, so let's go ahead and do the same thing with our 9 right here. So 9 goes on the outside. On the inside, 2,119. So how many times does 9 go into 2? Well, it doesn't, so I'll have to add a digit. So how about 21? Well, twice. So we come through and multiply. 2 times 9 is 18. And then I subtract there to get 3, and the 1 comes down. So how about 9 into 31? Well, that occurs 3 times, and 3 times 9 is 27. And I'll be subtracting that, so change the sign. And when I subtract, I'll have 4, bring this 9 down. How about 9 into 49? Well, it looks like 5 times, and 5 times 9 is 45. When I make that subtraction, I have 4. So this guy actually functions as my remainder. What does that mean, though? Well, it means that when I take 2,119 and divide it into groups of 9, I have 235 whole groups, and then I've got 4 left over. So the way we write this quotient, then, is 235, and typically we just say R4 or remainder 4, but I actually want to say 4 over 9, so it's 235 is the whole part, and then 4/9, because our divisor here was the 9. So that's a quick reminder of how we use this division algorithm, and again, this is the one taught in the United States typically. And I'm going to show you that this is exactly the same as what we're going to do with division with polynomials. So in this first example with polynomials, I have this cubic polynomial with 4 terms, and I'm going to divide that by this linear binomial. And I'm going to set it up the same exact way. I'm going to put this x minus 2 out front with my little bar here. And then I'm just going to go ahead and slip this polynomial inside here. And we have this. Okay. So previously we said, you're right, we looked at the term out here and we said, well, how many times does this go into this? So we're going to change that only slightly, and we're going to look at the first term here and the first term here. And we're going to say, what do I have to multiply by x, or multiply by this, to get 6x cubed? Or you could say, what's 6x cubed, this first term, divided by x, this first term? Well, ultimately we're going to get 6x squared. And so since it's an x squared term, I'm going to go ahead and line it up vertically with this x squared term, and I'm going to say 6x squared. And so then we're going to come back through and multiply. And when we multiply, we'll have to multiply by both of these terms. So I'm going to distribute the 6x squared across both of them. And then I'm going to once again line up all of our like terms. So 6x squared times x, well, that's just my 6x cubed. And then 6x squared times negative 2, and that'll be negative 12x squared. And I'll put a line here. So what we're going to do right here is you have to subtract these, but the subtraction I feel is a little easier if you just change the signs and then we end up adding. Okay, so we're going to change the signs and go through and add. So 6x cubed minus 6x cubed, well, those just cancel, and that's by design. We need those to cancel. And then negative 19x squared plus 12x squared, that's going to be negative 7x squared. And then I'm going to go ahead and bring down the next term. Okay, so exactly the same process. So next line. So I look at this x and I look at this negative 7x squared. What do I need to multiply by x to get negative 7x squared? Or of course you can go the other way and say negative 7x squared divided by x. Either way you're going to get negative 7. And we're going to go ahead and put that negative 7x right above this 16x because they're like terms. And then I'm going to go through and distribute. So negative 7x squared, and then negative 7x times negative 2 is plus 14x. Okay, and there's my little line. And since we're subtracting, what I'm going to do again, I'm going to change the signs and add. Okay, well the negative 7x squared and the positive 7x squared cancel. Once again, that's by design. We need it to happen that way. So then we have 16x minus 14x, that's 2x. And then this negative 4 is going to go ahead and drop down. Okay, so last one, because this is the last term to bring down. So x times what gives us 2x? Well, that's going to be a positive 2. So I'll write it up here so my constants align. And then I'm going to distribute this 2 through both of those terms. And I get 2x minus 4. And this is a good sign here. So we're going to go through, change the signs here and here. And what do you notice? Well, this cancels and this cancels. So I have nothing left over. So a remainder then of 0. And remember, if there's a remainder of 0, it means that this linear binomial x minus 2 evenly divides this cubic polynomial. And when I divide, the quotient I get is this 6x squared minus 7x plus 2. In this last polynomial example, we have this cubic polynomial again, 6x cubed minus 5x squared minus 17x plus 9. And we're going to divide that by this linear binomial, 2x plus 3. So if you want to see when this divisor is quadratic or we're missing terms, I'll have a link for that video down in the video description. So this one is just kind of addressing the general algorithm for long division for polynomials. Okay, so let's go ahead and write that 2x plus 3 right here, and with our bar, and then we'll put our polynomial here. So 6x cubed minus 5x squared minus 17x plus 9. Okay, so same kind of thing. First term to first term. What do I need to multiply by 2x to get 6x cubed? Well, I need to multiply by 3x squared. So I'm going to go ahead and put that 3x squared above my negative 5x squared so I can keep those like terms vertically aligned. And then I'm going to come back through and distribute here. So I'll get 6x cubed for that first one, and then 3 times 3 is 9, so positive 9x squared. Okay, so we are going to change the signs, so this positive becomes negative, and this positive becomes negative. We notice that the 6x cubed terms cancel. That's good, that's by design. So negative 5x squared and negative 9x squared is going to go ahead and make negative 14x squared. And then I'm going to go ahead and bring down this negative 17x for the next term. So, first term to first term. What do I need to multiply by 2x to get negative 14x squared? Well, it looks like negative 7x. So I'll put negative 7x right there and make sure these x terms align vertically because they're like terms. And then I'll come back through and take that negative 7x and distribute them across this divisor 2x plus 3. So I'll have negative 14x squared, and then it looks like a negative 21x. Okay, so come back through, change the sign, so this negative becomes positive, this negative becomes positive. you'll notice these 14x squareds cancel out, and that's by design. And so we have negative 17x plus 21x, and that'll be 4x. And then I'll go ahead and bring this plus 9 down as well. So we have 2x plus 3. So first term and first term. So what do I need to multiply by 2x to get 4x? Well, it looks like just a positive 2. So I'll put that plus 2 up there, come back through and multiply. So 4x plus 6. Okay, well, not quite the same. Let's go through, change these signs so we can subtract. The 4x's cancel. But we're left with 9 minus 6, which is 3. So this is going to be our remainder right here. Well, how are we going to deal with this remainder? Well, the same way we did when we divided the whole numbers. So I'm going to go ahead and write this quotient polynomial. It's 3x squared minus 7x plus 2. And then I'm going to say plus, because this is positive. If this was negative, I'd put a minus right here. Plus 3, which is my remainder, over that divisor 2x plus 3. So that's how we're going to deal with the remainders. We're just going to write it kind of as a mixed number like we did in that second example with the whole numbers. So when you're doing polynomial long division, it won't always come out evenly. Sometimes you will have a remainder. And when you do have a remainder, you're going to write it in this mixed form where you have the whole quotient, so our 3x squared minus 7x plus 2, which was from up here. And then, if this remainder is positive, I'll put plus. If this remainder is negative, I'll put minus. And then I'll put the number part of it, so the 3, over our divisor, 2x plus 3. So that's kind of a quick introduction to long division with polynomials.